Hello and welcome to lesson 2 of week 4. My name is Mildred. In this lesson, we are going to continue from where we stopped in the last lesson, looking at how to convert our if statement to a loop. Now, a loop is used when you want to perform the same operation multiple times until a condition is met or as long as a condition is true. We have two types of loops in Python. We have the for loop and then we have the while loop. Last week we looked at different sequence types. We look at the string, we look at list, we look at set, we look at dictionary, and we look at tuples. And all of this uses the for loop to loop through the items that are present in each of the variable with this data type. So we have a list of age groups here, and we said we don't want to use a conditional statement to say if x is in something. We saw an example how we put if x is in group 1 in the last lesson, since group 1 holds the list of the age groups. We also saw an example of how to use the range function. The reason I have this example is so that you can understand the logical reasoning that you need in programming, and it doesn't come so easily until you begin to try things like this. So how do we change this? I don't want to use the if statement to work with this range. I want to use the while statement. The while statement is a loop in Python, and we can say while x in range this. So now when we use while, right? So while x is in range 0 to 5, print this, x plus equal 1. Now, what I've done here is to say while x is in 0 to 5, 0, 1, 2, 3, 4, you want to print x is in age group 0 to 4. We want to increment because now we are using a loop, which means that it's going to look at the value of x and it's going to go through a range of numbers 0, 1, 2, 3, 4. And if x matches any of the number in this range, it will print x is in age group 0 to 4. That is not the case. We have nothing printed out. But let's say x is 3, for instance. Then it will print out what we want. X is in age group 0 to 4. Now, why did it print it out twice? Because it went through 0 first, it went through 1, it went to 2, went to 3, right? And then it matched at 3, and then it printed out x is in age group 0 to 4. It incremented by 1 and then did it a second time, and then it reached the end of the range. Now, when you have an assignment that asks you to figure out how to do something, you are going to stagger around trying to use different things that exist. And when you practice like this and you begin to turn around to see how this is going to work out, then you're going to see that this gives you the output, but it's printing it more times than you want. So what do you do when you want it to print it out once and then stop? We have a break statement and then we have a continue statement. When you use a break statement, it just means that it stops as soon as it encounters that once. So let's say we use break here. So let's use it there. We'll break here and then the printout will be at the end, and then there'll be no x plus equal 1. When I run this, I'll have it printed only once because I use the break statements to say once you hit the target, stop. If I want it to hit the target and then skip and continue, I can use a statement called continue. So what it does is, let me clear here so you can see this. It's going to have an infinite loop because it's continuing and I didn't put an increment operator there. Continue, you can now put x plus equal 1 like this. So we're incrementing, then print. So this time, let me interrupt this because it's an infinite loop. You will have it's still running infinitely because we put continue and we have to put the x plus equal 1 first. So the continue statement doesn't actually work here like this. Let's see. And then we run this, print it out just once because it increments, it skips that increment and then it prints it out the second time. Now, while this continue here is not the correct way to do it, it gives us the correct result. Now, one thing you want to take note of is that when you write your code, you can have a method that you use, maybe trial and error, and then this code gives you the result you expect without any errors, and you now feel that this code works, it gives us the output. Let's use it like that. It's not the most efficient code, it's not the best way to write it. You might not have an error while you test, but when you get to production and it meets an unexpected value, you cannot trust when this code will fail, and that's what now comes out as bugs, and you say there's a bug in the system. It was working all right, but all of a sudden is giving unexpected output on certain inputs. So the continue here, if you look behind the hood, what it does is 3 occurs only once in the sequence, but recall that when we did it the first time, we printed out twice, so it just keeps the first print and prints out the second time. So what works and what is correct here is the break statement, and you don't increment when you put that break statement. So now that we have looked at how we can convert an if statement to a loop, now recall that we have several conditions to meet, and we use a loop to say while x in range 0 to 5, do this. We also need to do that for 5 to 9, 10 to 14, 15 to 19, 20 to 24, 25 to 20. So is a loop the best way to solve this kind of problem? No. While you can use it temporarily to have a fix and get the solution you want, you can now see between using the conditional statement, the if and the match statement, and using a loop, what makes more sense. If you type import this, let's do import this here, and you run, we have the Zen of Python that tells us the things that we need to look out for when we write our code to be sure that our code meets a standard, or our code is as efficient and optimized as possible. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Readability counts. Alright? There should be one, and preferably only one, obvious way to do things. Errors should never pass silently. And so by the time you write your code using these different methods and you come back to look at the Zen of Python to ask yourself if this is the best way you can write the code, you want to ask yourself, is this implementation hard or easy to explain? If it is hard to explain, it is a bad idea. If it is easy to explain, it may be a good idea. In the case of having errors that fail silently and you never know about it until an unexpected input comes in, you have something there that says error should never pass silently. You want to make your code as readable as possible. You want to make your code simple, and if it can't be simple and it's complex, you better not make it complicated. So while you practice and walk around with this, the conditional statements and the loops, you want to see what is the best way. And in the advanced course, we are going to look at how to time functions when we write different ways of writing code, and we time the function to see which executes faster. And then we're going to use things like data structures and algorithm to see what is the worst case execution time for the different methods in which we write our code. So let's look properly now at loops in Python. When you have something you want to do over and over again until the condition is met, or as long as the condition remains true. So let's look at, for instance, we have a list. The list is my student, and my student is equal to, I'll just provide random names of students, and I want to loop through this list. When we use a loop, we can only loop through a sequence or an iterable. So when we talk about sequence or iterable, we're talking about a string, a list, a tuple, a set, a dictionary. Everything that is like an array is what we can loop through. Why? Because they have multiple items. And when we come here, Alice, Bob, Charlie, David, you see my cursor moving around is the iterator. How do we specify the iterator? We can use anything we want for the iterator. For instance, I want to say for. For is a statement we use for loop in Python. If I say for, I want to give my cursor a name, or my pencil, or whatever I use to touch each of these items as I pass through. I can say for I in, so we use the in operator, and then the name of the variable that holds that list. So for I in student, what do I want to do if for I in student? So as long as my iterator is here, loop through each of them and do something with each of them. Maybe I want to print out each of them. And so when I print out, I'm printing out I. Why am I printing out I, the iterator? Because when the pencil comes here, it is Alice. It prints out Alice. When it comes here, it is Bob. It prints out Bob. Charlie, Charlie, David, Eva. So it prints everything out in sequence like that. So when I run this, I have Alice, Bob, Charlie, David, Eva, Frank printed out one after the other as it loops through. Now we still talk about indentation and scope. You can see there's a space here because you want this two code or this block to execute together. It is the same thing we do with the dictionary, with the tuple, with the set. We can change this into a set like this by putting the curly brace, and this becomes a set. And this will still print out, and it will print out the same way. But with a set, we say the order is not known in advance. So you can see it printed out in any order, not necessarily the order like this. We can change this to a tuple by changing this to a parenthesis like this, and we have printed out in the order. Let's have a dictionary, and let's make it like a nested dictionary. So let's say I have my student here, and I want to have, let's say I want to have the student's name as the key. Then the value will now be maybe the age of the student and the grade of the student. So let's do that. So I have this student dictionary. I want to provide a key, which is the student name, let's say Alice. And then the value for Alice will now be a dictionary of name value pairs of Alice's age. So Alice is 20, and then the Alice's grade. Let's put it in this dictionary. We want to have this nested dictionary so we can provide a different, deeper way of looking at loops Python. So like we saw last week when we look at dictionary, we can have this as student 1 different variables so that it will be neater, and we'll have student 1 here, this is student 2, this is student 3, or we can just have it as a nested dictionary. When we get to JavaScript object notation towards the end of this course, you will see why it is necessary for you to understand nested dictionaries, because when you build your softwares, you have endpoints or routes in your APIs. Now, when you want to have interoperability where your system can communicate with other systems. Let's say, for instance, you have pharmacy system at the pharmacy, and you want the pharmacy system to be able to be connected to an insurance system, and an API that is used where it has a link that collects this information from the insurance system about the same patient using a unique identifier for the same person, and it sends this data in JSON format, and this comes as JSON. When JSON is passed in Python, it becomes a dictionary, and you won't know in advance, well, except you look at the API documentation, what the different keys and the values are in this result that is returned by the API. And so the result always looks something like this by the time you get your response, and your software should be able to pass that response to display the information that the user wants to see. So maybe the pharmacy wants to see if the insurance covers that drug before they give it to the patient, and how much is the copay or the patient needs to pay. So at this point now, the dictionary will return different values like the name of the insurance company, the member ID, the copay, the insurance plan, and all that. And then the pharmacy on their system, it can automatically do this in real time. It displays on the page. Now, you who look at the interface will not know what is going on behind the hood, but what is going on there is that this pharmacy system has communicated with the insurance system. It has looked up this person and seen that this person has this insurance that covers this drug, and just puts a final price. And what the pharmacist does is, this is cost you to pay here, take your medication. And it looks so good and so fast, but a lot of things have happened behind the scenes, and this is the kind of code that goes on behind. When the pharmacy system is written in Python and the exchange format is JSON, when that result returns, it looks something like this. So how do you pass this to be able to get out the information you need? So it gets down the list of everybody that has insurance. But you don't want everybody, you want to talk about it and only. You want to see information about it and only. So maybe you have the key, which is going to be the unique ID for Ethan, and that is going to be the key for this. And so what it does when you enter the patient detail is to go look for Ethan and brings only the result for Ethan displayed for you on your screen. So let's see how we can loop through this to find only one value, or loop through is to print out all the values and then start working on each value. We use the for loop like this. For now, we want an iterator. We can say our iterator is I like previously, or we can even say for students like this. So we'll say for students, which is the key, and we want value that key. So let's say for students details. So let's say the value is details, or you can say for key value, whatever name you want to put in as your iterator. So we want to look at for the key and the value in the name of the variable my students. Now, it's not going to be in my students alone. Remember that when we look at dictionaries last week, we look at the different methods that dictionaries have. We have the items method that gives us a tuple of the key and value of each of the dictionary item, right? So we can say for student details in my students.items. So what we are doing here is to loop through that tuple of the key and the values that is provided in this loop. The key is stored in students, the value is stored in the details. So we'll say for student details in, or you can say for key value in my students.items, we want to do something. We can also use a conditional statement here to say, let's say we want to say if the students is less than 21 years old, we want to print it out. The student is less than 21, the student is equal to 21, the student is greater than 21, and we want to say something about the grade of the same student. So we want to say something about the age, we want to say about the grade. So I'm trying to create a complex scenario, which is usually the case when you develop softwares, that you have a sign-up form and you don't want anybody less than 18 to sign up. They fill the form, you get the values. You want to calculate the current year minus the year of the birth of the person to get the current age, right? And so you do those calculations and you say if the age comes out to be less than 18, you want to display a message on the screen to say you cannot access this site, you are less than 18. Or if the person is equal to 18, you want to redirect them to a page where they save their values, or you want to give them a welcome message, or you want their account to be created. So you have different things you want to do for the different age group. So one other thing again is then you go to to get a driver's license, and they want to print out your card, and we want to know if this person is less than 21 years old. You want it on the card and things like that. So I'm giving you a real life example of how this is useful, so you can work on your imagination to think about every scenario where every code you write is useful and how to make it better. So I want to say if, so the value now is details, right? This is the key, the value. So I want to say if that value details. So if details, so the value is held in detail, right? And the value is a dictionary of name value pairs of age and grade. And so when we have details, we want to get the key that is in the detail. So we want to get an item from it, which is age, and age is stored in with the age key. So if details age now is less than 21, we want to do something. Let's say print, and let's use the format string and say we just want to print the student name, because the student is the key, right? So when we have this, we can say student is, so we can use the elif because we have just 3 conditions. It's either less than, greater than, or equal to. We can use an if condition to do if grade is equal to A, student has an excellent grade of A, things like that. So we'll start another if condition, if grade. So now we did if here, I can just change this to elif. So we have 3 grades A, B, C. So I do if, elif, else, and then I'll just print, just an empty print, just to give us a new line. Okay, so we have this like this. We want to loop through all of the items of this, and we want to talk about their age and their grades. Let's try it. So now we have it printed out from the beginning. Alice is less than 21 years old. Alice has an excellent grade of A. So we have, let's look at Ethan. Ethan is less than 21 years old. Ethan has a good grade of B. So you can see how we use this loop in a complicated way, especially when we have dictionaries. So this will help you to understand how we work on complex scenarios, or how we can do multiple things at a time in a block of code. Now we use the if, elif, else statements. We can still use the match statement like we did in the previous lesson to see the match condition. So maybe here what we are matching is details age. So we can say match details age. So we match details age, and I'll remove all these conditions. Let's see how we work with match. So we match the age, and then we say case age. If age is less than 21, then we want to print. Then we'll do the same case for case 21. When we print student is 21 years old. Student is exactly, and then we have the catch-all case underscore, and this will be if student is greater than 21, it will print student is over 21 years old. And then we do the next match case here, and what we are matching now is the grade, and then we say case student has a satisfactory grade of A. So we've used the case statements to do this, and instead of writing case C here, we can just use the underscore catch all here, because if it's not A, B, it has to be C right there. So let me clear this. So we have it printed out. We didn't print out the line to make it neat here, so we can just do a print here, so we get it neater to give us something, a line between them, each of the students. So Alice is less than 21 years old. Alice is an excellent grade of A. So for each person, it inserts their name, because we put the iterator or the key that holds the name here. So you can see different ways of doing the same thing. You want to practice more, explore more, do everything that we did about trying to use the while loop instead of the if statement, see if it gets complicated, if it gets easy, if by chance you get the thing working right, and you can get unexpected behaviors. All right. So we've looked in summary at how to use the break, the continue statements, the match statement within conditional and loops, and we're going to look at how we can handle errors in the next lesson.